All right, we have more definitions. Geometry has a lot of definitions. Perpendicular lines are intersect and create four right angles, which remember are 90 degrees. Okay? If they don't intersect and create four right angles, they're just intersecting lines, they're not perpendicular lines. Parallel lines, these do not intersect at all. Okay? And they are the same distance away from each other. Ever. And then you have one more, and it's called skew lines. And skew lines do not intersect, and they are not parallel. Which will make more sense when we get down to some examples. So they want you to look at that diagram, and we are going to be saying whether the lines that they give us are parallel, perpendicular, or skew. So the first ones they give us are line AB and AC. Now let's look at where AB and AC are. AB is here, and AC is here, okay? And when they intersect, that is going to intersect and create four right angles, so they are perpendicular. And if you don't like to write the word perpendicular out because it's a long word, that is the symbol for perpendicular. The next one they give us is line CE and BD. So let's look at CE and let's look at BD. Now this is skew lines because they're on the same plane. They're on the same plane, but they're never going to intersect and they don't run the same way, so they're not parallel. So we could just write skew. Okay. Last one we're going to look at for this example is they give us AC and BD. So let's look at those. AC and BD. Okay, they're the same distance away from each other, and they're never going to intersect. So those are parallel. Parallel has that symbol. Okay? So now we have more definitions. The next word we have is adjacent. Adjacent have a common vertex, but, and a common side. Okay? So, an example of that, if you had these two angles here, and we said this is angle 2 and this is angle 3, they're adjacent because they share this side. Okay, that side is part of angle 2 and it's also part of angle 3. So that's how you know adjacent angles, they share a side. And then we have vertical angles. And they are opposite angles, not angels. angles formed by intersecting lines. Remember, intersecting lines don't have to create 90-degree angles, those are just perpendicular. And these angles have the same measure. You can see those a lot in going outside and looking up in the sky. When one plane flies and then you see it and it leaves its dust trail or whatever it's called, contrail, and then another plane flies and intersects that contrail, it creates vertical angles. So vertical angles look like this, just like the diagram above. Okay, just any. This angle here and this angle here are going to be equal, and this angle here and this angle here are equal. So these are equal. If you don't have different colors, don't necessarily write this down. And these are equal. Maybe I would make the little tick marks, which in this case are not looking like our normal tick marks of our line, but our arcs that show those are equal. So the ones with one arc are equal and the one with two arcs are equal to each other. Next word we have is transversal. It's kind of a big word. And it is a line that intersects two or more lines that lie in the same plane. So what that means is if you have, oops, might need something to write with. These two lines, this line here is the transversal. So this is the transversal. Okay, now we have some interesting stuff about this. I'm going to use colors. It'd be awesome if you have colors. These two lines, or angles, are congruent, which means they're the same. But these are also congruent because they're opposite. And these, oops, two, and this one are the same. And these are the same because they're opposites. Okay? So that's some ways we can look. We can also look at some other diagrams of this picture. And we can say following is true. We can say that this and this are equal, like we talked about, and this angle and this angle are equal, like we talked about. Those are called alternate interior angles. They're both inside of these lines, and they lie on opposite sides. Alternate would be in alternate places. Another word to put that would be opposite sides. So another picture we can look at shows the following. We're just going to look at the outside angles now, outside the two lines. These two are equal, like we talked about before, and these two are equal, just like we talked about before. And since they lie outside, another word for outside is exterior. These are alternate exterior angles. I would really write those pictures down with your tick marks or your little arcs. But we have one more to draw. So I said that too quick because we have one more to draw actually. I thought it was the other picture we drew, and it's not. This last one, we're just going to look at some different places, corresponding angles. That means they lie in the same place but on the two different lines. So, for example, this angle and this angle are corresponding angles because they're both on the top and to the left of the transversal. This angle and this angle are both on the top and to the right. This angle and this angle, because they're both beneath and to the left. And then, one more color, this angle and this angle, because they're both beneath and to the right. So we have corresponding angles, they lie in the exact same spot. Now we're going to use angle relationships to find angle measures. So we're going to use this diagram. It's on page 323 in your book if you can't see it very well. So we are looking for, first of all, the angle 6. So the measure of angle 6. So this is 6, okay? And we know that this angle is 55, and this angle, 55-degree angle, and 6 are in opposite places, so they're opposite angles, which means that angle 6 has to equal 55 degrees as well. Okay? So then, our next one is angle 1. Now, we just talked about congruent angles. So we're going to look at this 55-degree angle and angle 1, and they're both below and to the left, so they're corresponding angles. They're in the same place, so angle 1 also has to be 55 degrees. Then we're going to look at C, which is the measure of angle 7. Okay? So if we know that this is 55 degrees, we knew this is 55 degrees, right? Is it true there's a vertex right there, and we have a angle going that way and an angle going this way, right? So that creates a straight line, which means a straight line has 180 degrees, and this simply tells me that I've used 55 of the 180 degrees. So if I've used 55 of the 180 degrees, I can subtract that and get 125. So angle 7 has to be 125 degrees in order to make this straight line actually have 180 degrees. And then D says angle 3. Well, let's look at angle 3. Angle 3 is here. Now if we look at the corresponding angle, since it's on the upper right side of this line, we're going to look at the upper right side of our top line, and it's 55. And since they're corresponding, they're in the same spot. So if they're both on the upper side to the right, they're 55 degrees. And E is angle 4. So angle 4 is right here, right? And if I look to its corresponding side, its corresponding angle is going to be here because it's both of those angles are above and to the left. And we know angle 7 is 125, so angle 4 has to be 125 degrees. Okay? I don't know why I changed colors. F wants to know the measure of angle 2. Well, we just said 4 was 125 degrees, and 2 is in the opposite place. So if it's in the opposite place, it has to be 125 degrees. And then the measure of angle 5, we can either look at, hey, this and angle 5 are in corresponding spots, so it has to be 25, or 7, which is this angle here, is in the opposite spot as angle 5, so it has to be 125 degrees. So with just one angle measurement on transversals, you can figure out what every other degree measure is, all other 7, just having one little bit of information.